feel confident in our team's abilities to ramp production quickly, know that it is an unprecedented change. And
this is the exact design of Tesla's affordable model, the Tesla Model 2, that we'll get to see this November at Tesla's biggest event of the year. Recently, several Model 2 prototypes were spotted again in Texas, and a new video gives us the most detailed look so far, at least 20 differences compared to the Model Y. From simpler body panels and a more streamlined sensor setup to an interior with fewer parts, every change serves one goal: cutting costs so the price can drop to just $15,990. In the past, Elon Musk confirmed that the Model 2 is basically a scaled-down version of the Model Y, but the leaks suggest Tesla isn't just removing features, it's re-engineering the car.
Because it's probably have a few bugs, but it's going to be very cool. You'll want to invite your friends over and say, check this out.
This acknowledgement of all the differences is splitting the community. Some people feel disappointed about the reduced comforts, while others support the keep what matters approach to bring the price down for the Model 2. So the big question for buyers is, where did Tesla cut, and how did they cut to keep the experience reasonable on the Model 2? We'll walk through every change and see whether a price under $16,000 is truly a deal for what you're getting. Staying true to tradition, Tesla has become more tight-lipped than ever. New models are kept under wraps until the very last minute. Test cars are covered from nose to tail, even the cabin with plastic panels. They've been spotted on the road many times, but no one can say for sure what's changing. That's why most of what we've heard about the Model 2 has been speculation, based mostly on the budget price Elon Musk once mentioned. But a newly leaked video from Texas changes the picture. For the first time, we get a close, clear look at Tesla's affordable model, cutting through the guesswork we had from earlier sightings in China or on the streets of Fremont. From what we can see, there appear to be more than 20 meaningful adjustments. In the video, the car is still camouflaged, but instead of catching it driving, it's parked in a lot, so we can study it more closely. From the footage, the front end and headlights of the Model 2 look almost completely redesigned. Even though part of the nose is still covered, you can see the headlights sit higher now, and the horizontal LED light strip is gone, a detail that usually makes Tesla's pricier models look more upscale. On the Model Y, for example, the headlights sit beneath a sleek LED strip that helps elevate the SUV's appearance. But that approach doesn't really fit a car aiming to stay under $20,000. With the Model 2, Tesla seems to be going minimalist. A simpler headlight layout that feels closer to earlier Model Y designs, rather than the more premium look you'd expect on a $50,000 vehicle. Another interesting detail: the Model 2 shows a camera mounted on the front bumper. That's not too surprising. During the second quarter earnings call, Elon Musk hinted the budget model would still support full self-driving FSD. In other words, Tesla has little reason to remove FSD-related hardware just to save a few $1,000s. The most debated change may be the roof. There's a good chance this will be the first Tesla without a full panoramic glass roof. Instead, it appears to have a single-piece metal roof, painted the same color as the body. This choice could make the cabin feel a bit less open and airy, something many fans love about Teslas with glass roofs, and it may influence the decisions of some buyers. Even though the rear is still covered, one thing stands out. The signature horizontal light bar on the Model Y's tailgate is gone. Instead, the Model 2 appears to use simpler, more traditional brake lights. From the video, the wheelbase looks similar to the current Model Y, so the Model 2 may not be as small as the rumors suggest. The 19-inch wheels reinforce that same size impression. If that's the case, the cabin space, legroom, and cargo capacity likely won't differ much from the Model Y, an important plus for buyers. As usual, Tesla's test cars keep the interior well covered, and this one is no different. Even so, a few changes are visible. There's no rear seat entertainment screen. The audio system appears trimmed back with no speakers in the A-pillars, and the seats switch to fabric upholstery instead of vegan leather, similar to the Model 3 configuration assembled in Mexico. These are all expected cost-saving steps. Vegan leather typically adds about $350 to $400 compared to fabric, so cloth seats are a sensible way to cut costs. The car also drops seat heating and ventilation. The speaker count looks reduced from around 15 to about 10, which should save at least another $300. Looking closely at the center area, the console has been redesigned and sits lower, tucked beneath the main display. The cup holder layout is reminiscent of the Cybertruck. For interior lighting, while the Model Y offers RGB accent strips with multiple color options, the Model 2 sticks to a minimalist approach. A simple white ambient strip, practical and cheaper to produce. So how would the Tesla Model 2 deliver an estimated 310 miles of range? If we keep assuming the Model 2 targets a $15,990 price and roughly 310 miles, the battery choice becomes the key gear that determines both cost and performance. The most likely setup today would be an LFP pack of about 53 kilowatt-hour, paired with good aerodynamics, lighter weight, low rolling resistance tires, an efficient drive unit, and smart energy management software to squeeze more miles out of each kilowatt-hour. LFP has advantages in cost, safety, and lifespan. Its energy density is lower than NCA or NCM, but that's okay when the whole car is designed to support it. With that in mind, the idea of switching the Model 2 to aluminum-ion raises a fair question. How would the range change, and would the $15,990 price still hold up? First, in principle, aluminum-ion batteries are attractive because aluminum is abundant, inexpensive, and safe. The electrochemistry allows ions to move quickly, so there's potential for very fast charging and strong power output. For a daily driver, that could be a big benefit. Shorter charging stops, while still adding plenty of miles. However, the sticking point is energy density. Most aluminum-ion projects today are still experimental or semi-commercial, mainly for stationary storage. Their WH per kilogram figures are generally much lower than LFP, let alone NCA. Put directly into a car, that lower energy density creates a trade-off. To keep an estimated 310-mile range, Tesla would need a larger battery pack, which adds weight and cost, or they'd have to accept a shorter driving range. Let's say Tesla wants to keep the full 310-mile range. If the battery has lower energy density, the pack has to be bigger and heavier. That extra weight hurts efficiency, so you get fewer miles per kilowatt-hour, a frustrating feedback loop. Tesla could try to offset this with stricter aerodynamics, a smarter mix of aluminum and high-strength steel in the body, more efficient motors and inverters, and even special low-rolling resistance tires. But none of that is free. Premium tires, carefully chosen materials, and more complex casting and machining all add cost. At a $15,990 target price, every extra dollar has to be justified. The most reliable way to earn back cost is still to keep the battery pack compact, thanks to a chemistry with good enough energy density. That's exactly where LFP shines. Today, strong cost per mile, without breaking the budget. If we accept a shorter range, the picture changes. A Model 2 with aluminum-ion batteries targeting, say, 230 to 260 miles could still cover most daily driving in the US, which averages around 40 miles a day. This is especially true if ultra-fast charging is a natural strength of aluminum-ion. Shorter stops at a charger could make up for the lower rated range. With a dense charging network and smart trip planning software, the real-world experience might still feel just fine. That said, the market has gotten used to seeing 3XX on the EPA label. Dropping below 300 miles would require very sharp messaging and truly excellent charging performance to calm range anxiety. When it comes to cost, aluminum is common and inexpensive, but battery chemistry isn't just about raw materials. The whole supply chain matters. Cathodes, anodes, electrolytes, coating processes, solvents, factory equipment, humidity control, fire safety, and drying systems. All of it takes time to standardize. Tesla is very good at scaling quickly, but switching from LFP to aluminum-ion would come with a real tuition cost. Investing in new production lines, improving yields, testing long-term durability, setting new quality standards, updating the battery management system, and dealing with different voltages and cell formats. In the short term, it's hard to see a young battery tech beating LFP on cost per kilowatt-hour, especially when LFP is already mature and produced at the scale of millions of cars. That's why the ambitious $15,990 price point would likely be at risk if the Model 2 moved to aluminum-ion right away. Over the long run, if the technology improves, energy density rises, and manufacturing gets cheaper with volume, aluminum-ion could become a new runway for lower costs. But that kind of tech-to-factory transition usually takes years, not months. One important topic is safety and thermal management. Aluminum-ion batteries have an advantage in thermal stability and higher safety margins, with a lower risk of thermal runaway than many nickel-rich chemistries. That could allow simpler heating/cooling systems and a leaner safety structure around the pack, reducing supporting materials and extra weight. If this advantage is big enough, those savings might partly offset the penalty of lower energy density. However, to truly bring costs down, we'd need long-term data. Hundreds of charge-discharge cycles, how much capacity fades over years, and how the batteries behave in very cold or very hot weather. LFP has already proven itself in real-world use, while aluminum-ion is just getting started. Ultra-fast charging is the ace up the sleeve. If an aluminum-ion pack can take very high power with a smooth charging curve, drivers will feel like the car has more range than the label says. A 10 to 15-minute stop that adds 150 to 200 miles would make the car much more versatile for trips. That said, ultra-fast charging demands more from both the stations and the car's onboard hardware, plus smart thermal management to protect the cells from stress. Those upgrades require high-quality components, and they aren't exactly cheap. We also have to think about infrastructure compatibility. The supercharger network is tuned for the voltage and current of today's battery packs. If aluminum-ion needs a different voltage profile, Tesla would have to make sure everything works seamlessly to avoid any hiccups in the user experience. Any big system-level differences become hidden costs. They might not show up on the parts list, but they do show up in network upgrades or added complexity inside the car. From a sustainability and recycling standpoint, aluminum-ion tells an appealing story. It relies on materials that are less sensitive to geopolitics, and its recycling process could be simpler than some traditional chemistries. If, over the long run, logistics and recycling truly become cheaper and cleaner, the total lifetime cost could come down, helping offset higher upfront manufacturing costs. However, when you're trying to launch a $15,990 car, the challenge isn't just lifetime cost. It's cash costs on the production line and being able to price competitively on day one. Balancing everything, here's the fair picture. If Tesla's non-negotiable goals are 310 miles of range and a $15,990 price, LFP is the more practical choice right now. It already has the learning curve, supply chain, and system performance to make that target realistic. Aluminum-ion could open the door to ultra-fast charging, higher safety margins, and plentiful raw materials. But to keep 310 miles, the car would likely get heavier and more complex, or the costs would push it beyond that price point. If Tesla were willing to rate the range below 300 miles and fully lean into aluminum-ion's fast charging strengths, the real-world experience could still be very appealing for most city drivers, shifting the message from go far in one shot to make short stops and keep going. But the actual cost savings would need to be proven. While aluminum-ion matures, the efficiency-first, capacity-second strategy built on LFP remains the shortest path for the Model 2 to hit both goals, far enough for daily needs and affordable enough for the mass market. How much longer until you can place an order for the Model 2? From what we're seeing, the vehicle's development is nearly complete, with no major regulatory or technical hurdles left. Tesla's proven self-driving platform, manufacturing know-how, and mature supply chain give it a real edge, so the Model 2's debut could arrive sooner than many expect. When Tesla does unveil it, pre-orders typically open at the event or shortly after. In short, ordering may be closer than it feels. While the 2025 event will mark the Model 2's formal introduction, it's more than a simple prototype showcase. Tesla appears to be positioning itself for rapid production soon after the unveiling. Thanks to its well-developed global manufacturing network, the company is prepared to transition swiftly from concept to large-scale production. At Giga Texas, where around 5,000 Model Ys are built weekly, expansion plans are already in motion to include the Model 2 alongside the Cybertruck and future projects like the CyberCab. Meanwhile, Giga Fremont and Shanghai are projected to be fully operational to serve as a major hub for Model 2 manufacturing. Giga Berlin is also increasing capacity, with production flexibility expected to accommodate new models in the near term. With multiple factories scaling up and infrastructure already in place, mass production following the 2025 reveal looks highly plausible. Tesla's technology, experience, and streamlined operations could make the Model 2 a defining step toward affordable electric mobility. Tesla's playbook for its entry-level car is clear. Prioritize cost discipline over frills. Rather than layering on luxury, the company is said to be trimming features wherever the trade-off doesn't hurt core utility, the way you would for a mass-market smartphone that has to hit a headline price. In that context, the so-called Model 2 has been framed as a compact crossover in the Model Y mold. Strategic, because it could leverage existing assembly know-how and, in theory, portions of the same manufacturing footprint. That vision contrasts with early expectations that the car would be a hatchback. A hatch would be smaller and simpler, and it would mark a first for Tesla, whose lineup has historically orbited sedans and crossovers. To some shoppers, a footprint closer to a Nissan Leaf or Honda Civic sounds appealing. Easy to park, efficient, and friendly for urban living. Yet, the U.S. market still skews heavily toward crossovers, which complicates the business case for a true hatch. This is where manufacturing pragmatism meets product planning. A crossover-shaped Model 2 can piggyback on proven Model Y processes and supplier ecosystems. A clean-sheet hatch might demand dedicated tooling and even a distinct body shop flow. Standing up a new body style isn't free. Every bracket, casting, wiring length, and seal has a cost and a learning curve. So reusing what already works is often the path of least resistance when the target price matters more than novelty. Price, of course, is the story. Reports and leaked references have floated a jaw-dropping base figure of $15,990 for a rear-drive standard model, not counting any federal credits, which may or may not apply depending on content and rules, at launch. An all-wheel drive or extended-range variant, if it materializes, would naturally sit higher. That sub-$16,000 headline, well below the long-teased $25,000, would immediately reframe the segment, particularly as Chinese competitors push down market with aggressively priced EVs. Whether Tesla can sustain such a sticker once batteries, labor, logistics, and warranty reserves are tallied is the million-mile question, but you can see why the number set forums on fire. Underneath, manufacturing is where Tesla historically finds outsized gains. The Model Y's move to large rear and front castings plus a structural battery pack cut part counts dramatically and helped drive major cost reductions. The next step, insiders suggest, is even larger casting for the affordable platform, potentially consolidating much of the underbody in a single piece. Smaller overhangs and tighter packaging make that vision more feasible on a compact vehicle. They also make older, lower tonnage presses insufficient, hence the push for bigger machines and new die technology. Fewer parts mean fewer welds, fewer robots, shorter lines, and quicker ramps, exactly what you need if you're chasing massive volumes. That ambition extends to demand forecasts, too. Elon Musk has talked about volumes that would eclipse combined Model 3 and Y totals, positioning the Model 2 as the most mass-produced vehicle ever. Skepticism is healthy until we see firm timing, pricing, and EPA-rated specs. If Tesla unveils the Model 2 in 2025 but deliveries slip to 2026 or 2027, would you put down a deposit now or wait until it's on showroom floors to decide? Please share your opinion in the comments section below this video.
That we started in North America, and that our goal is to maximize production with the IRA cliff ending Q3. We're going to be ready with the new, more affordable models available for everyone in Q4.
Tesla has officially confirmed that the upcoming affordable Tesla is not the Model Q, and the timeline has been set for the fourth quarter, specifically November 20th, 25. Recently, this model has been spotted frequently on public roads. We've noticed one key similarity among the two test vehicles believed to be the Model 2 in Texas and another one seen last week on the streets of Fremont. They all feature a completely redesigned B-pillar. It's much slimmer, with a smooth surface, and most importantly, there are almost no panel gaps, giving the car body a seamless and refined look. According to Elon Musk's earlier confirmation, the Tesla Model 2 will look similar to the prototypes already seen on the streets and will use an entirely new material to optimize costs. This ensures that both versions of the Model 2, set to debut at the November event, will stay under $20,000, with the base version priced at $15,990, or possibly even lower. So why did Tesla change the Model 2's design? What's the purpose behind it? And how will it benefit users?
And I think the revolution in manufacturing that will be represented by that car will blow people's minds.
To be honest, at first, aside from its attractive price, we didn't think too highly of Tesla's upcoming mass-market electric car priced at $15,990, often referred to as the Model 2. We've studied and compared its leaked specs with existing and soon-to-launch EVs on the market. And to be frank, there's nothing particularly impressive about it. Information and specifications about the Model 2 often surface briefly, then fade away without much attention. Simply put, the Model 2 doesn't stand out, nor does it show any clear signs that it could sell millions of units as Musk has claimed. Of course, not everyone agrees with this view. Many people are still curious and eager to see what Tesla has in store. However, recent leaks from inside Tesla suggest that we and many others may have completely underestimated this next-generation electric vehicle. Specifically, the Model 2 is set to become the most affordable EV in the world, while still maintaining durability, crash resistance, and highly optimized production costs. This is made possible by shifting from an aluminum alloy structure to high-strength steel for the vehicle's body. This upgrade not only allows Tesla to streamline its manufacturing process, but also significantly improves safety and reduces material costs. For the Model 2, according to internal sources from Tesla's Texas factory, the company is replacing most of the aluminum used in the vehicle's structure with high-strength steel, a technology previously seen in Tesla Cybertruck or other luxury cars. Surprisingly, it's not the premium models like the Model S or Model X adopting this new approach, but rather the Model 2, Tesla's upcoming mass-market vehicle priced at $15,990 that will fully implement and test this new material. According to Tesla engineers, switching to high-strength steel not only increases the vehicle's torsional rigidity by up to 20%, but also significantly reduces chassis production costs compared to aluminum alloys, which are more expensive and difficult to process. This move is seen as a key step in Tesla's strategy to make electric vehicles more accessible to the mass market. One engineer shared that high-strength steel may be heavier than aluminum, but by optimizing the design and combining it with advanced hot stamping technologies, we've achieved an ideal strength-to-weight ratio, while dramatically cutting costs. Looking back at the initial leaked specifications, the Model 2 was said to be about 30% lighter than the Model 3. However, with the material change, Tesla is completely redesigning the vehicle's body structure to maintain optimal energy efficiency. The company also noted that thanks to new steel processing technologies and a minimalist design approach, the Model 2 will end up being only about 5% heavier than originally planned. A fully acceptable figure considering the major benefits in safety and cost reduction. The use of high-strength steel also provides a major safety advantage. Internal crash tests show that the Model 2's body structure can withstand forces 1.5 times higher than current U.S. safety standards, offering greater protection for passengers. For a mass-market electric vehicle, this is an extremely valuable benefit, especially as Tesla aims to maintain its image as the safest car brand in the world. According to the plan, Tesla will implement a new hot stamping system and high-precision welding robots directly at the Giga Texas factory, boosting production speed and minimizing material waste. So how has the Model 2's design been adjusted to serve the mass market? The first noticeable feature is the very short wheelbase of this model. Looking back at sketches created by Tesla engineers and designers for this $15,990 vehicle, all of them show a compact length estimated to be around 160 to 165 inches if brought to production, significantly shorter than the Model Y or Model 3. In the leaked photo, most people initially assumed it was an unfinished Model Y prototype at Giga Texas, mainly because of the missing front bumper, which made it look somewhat odd. However, after comparing the angles and proportions with a nearby Model Y spotted in the same image, several clues strongly suggest that this is not a Model Y. When placed side by side, this prototype appears shorter, and its windows are noticeably bigger than those of the Model Y behind it, along with a much wider B-pillar. Normally, objects closer to the camera appear larger than those farther away, but in this case, the opposite is true, which makes one conclusion fairly easy to draw. Looking deeper into the vehicle's design details, such as the curvature of the front windshield, the angle of the hood, and other subtle differences in the glass, there's growing evidence that this is indeed an entirely new model. Another theory suggests that this could be a refreshed Model Y, part of a rumored project that includes minor updates such as redesigned headlights, rather than an entirely new vehicle. However, as far as we know, Tesla has never changed the size or proportions of its SUVs in a refresh, making this theory quite unlikely. Tesla's second quarter 2025 investor presentation mentioned that initial production of the low-cost model began in June. During the meeting, Elon Musk told investors that the vehicle would be available for everyone sometime between October and December 2025. Lars Moravy, Tesla's vice president of vehicle engineering, stated that the new models will look similar in shape and style to the cars we're currently producing. He emphasized that affordability, not appearance, is the main focus. During the meeting, Tesla explained the company's current limitations, noting that the low-cost models will be produced on existing production lines. This setup limits how much the new vehicles can differ in appearance, but it also allows Tesla to scale production without needing major design changes. According to the latest test prototypes, the main headlights have reportedly been moved back onto the hood, similar to the original Model Y, and lack the connecting light bar. Likewise, the rear end is expected to feature a simpler hatch design without a light bar and basic brake lights to help reduce costs. Although Elon Musk has not confirmed specific details, limiting the vehicle's acceleration and top speed would allow Tesla to equip smaller wheels, tires, and brakes, around 18 inches, further reducing costs. A smaller battery pack would shorten the driving range, but significantly cut material costs. Musk aims to tackle the affordability challenge of the Model Y by lowering monthly payments and reducing the starting price. The launch of these low-cost variants is currently planned for the fourth quarter 2025. Based on previous product line updates, the low-cost version is expected to exclude premium features. The software will likely be more basic, with fewer comfort and convenience options. Features such as the rear display, ventilated seats, power folding seats, sunroof, center console, acoustic glass, coat hooks, and higher-grade materials and seat upholstery may not be offered. According to Tesla, additional components could also be removed, including a simplified suspension, 2 audio system options, Essential and Essential with Commodity, no heating for the rear camera, and the removal of the airwave from the dashboard, all aimed at reducing the number of parts and electrical components. In addition, reports about the Tesla Model 2 indicate further simplifications: a fiberglass roof, interior lighting limited to the footwell area, single-axis seat adjustment, no power-folding mirrors, and no puddle lights. How did Tesla cut down on the battery pack with this new design? Tesla may be preparing to usher in another battery revolution, this time with the Model 2. The company is reportedly moving its first-generation aluminum-ion battery technology from the lab to production, potentially redefining what's possible for an EV priced under $16,000. Like lithium-ion cells, aluminum-ion batteries store and release energy through ion movement between the anode and cathode. But instead of lithium, they use aluminum ions, which carry 3 positive charges rather than 1. This gives them the theoretical ability to move 3 times more energy per ion, dramatically increasing energy density while reducing dependence on expensive rare earth materials. Each cell contains an aluminum-based anode, a graphene or metal oxide cathode, and a liquid electrolyte. Together, they promise higher energy capacity, lighter weight, and lower cost, crucial advantages for mass-market EVs. Reports indicate Tesla's A1 aluminum-ion prototypes have achieved over 700 watt-hour per kilogram in lab tests. For context, most lithium-ion cells today reach 200 watt-hour per kilogram, while Tesla's advanced 4680 cells manage around 275 watt-hour per kilogram. If commercialized, this would allow a compact EV to travel 700 to 1,000 miles per charge, more than double today's best offerings. Applied to the Model 2, aluminum-ion technology could transform affordability and range. A battery pack of similar size to the Model 3 long range could theoretically power 1,000 miles of driving. Even accounting for real-world inefficiencies, a 700-mile range would still be a groundbreaking achievement for a budget-friendly EV. The Model 2 is central to Tesla's mission of democratizing EVs. In the company's Master Plan Part 3, Tesla outlined a 53 kilowatt-hour pack for this model, expected to deliver around 250 miles per charge. Lightweight construction, roughly 30% lighter than the Model Y, boosts efficiency, while a long-range version could extend a range to 280 miles, priced around $28,000 to $30,000. For a sub-$16,000 variant, Tesla may initially rely on lithium iron phosphate or lower-cost lithium-ion cells. However, as aluminum-ion production scales, it could become the core technology behind the Model 2's future upgrades, offering longer range, faster charging, and reduced costs. Charging speed is another highlight. Tesla estimates 80% charge in 10 minutes, potentially 20 minutes in real-world use, well ahead of most competitors needing 30 to 45 minutes. The $15,990 price tag sounds ambitious, and maintaining it will be challenging. Tesla's margins fell to 16.3% in early 2025, reflecting aggressive price cuts and investments in new technologies. Rising tariffs, up to 125% on Chinese imports, and inflation add further pressure. Since 30% of Tesla's parts come from Mexico, trade shifts could increase costs by $2,000 to $3,000 per vehicle. To counter this, Tesla is localizing its supply chain. The K-Tel battery plant in Michigan, launching in 2026, will reduce reliance on overseas materials and help stabilize pricing. Tesla's Giga Mexico is also key, targeting 10,000 units per week, leveraging economies of scale to offset rising input costs. Still, US-based battery production remains expensive, $140 to $165 million per gigawatt hour compared to $110 million in China. If conditions persist, Tesla may eventually raise Model 2's price to $18,000 to $20,000, still affordable by EV standards. Chinese automaker BYD sells EVs for as low as $10,000 and posted 40% sales growth in 2024, while Tesla's China sales dipped. Yet Tesla's strength lies not just in price, but in brand trust, technology, and its software ecosystem, particularly full self-driving, features Chinese rivals struggle to match in Western markets. Rather than chasing the lowest price, Tesla focuses on value leadership, pairing strong range, safety, and software with an accessible entry point. The Model 2 is designed to outperform peers in efficiency, not luxury. Tesla isn't depending solely on car sales for profit. Software subscriptions like FSD, priced at $1,200 to $2,400 annually, could generate recurring revenue. If even 30% of owners subscribe, Tesla could offset hardware costs significantly. Regulatory credits add another buffer. Tesla earned $739 million in the third quarter 2024 alone, nearly triple the previous year, providing extra flexibility to sustain low prices. Tesla's strong balance sheet, $36 billion in cash reserves, allows it to absorb short-term losses for long-term market dominance. The company could realistically maintain the $15,990 price for 12 to 18 months after launch, through mid-2027, as it scales output and drives down costs. Even if early Model 2s use conventional cells, aluminum-ion represents the next leap. With higher energy density, faster charging, and no reliance on rare lithium, it aligns perfectly with Tesla's goals: affordability, sustainability, and performance. Compared to today's 4680 cells, aluminum-ion could halve costs, double range, and simplify recycling. Most importantly, it would break the current plateau of lithium-ion innovation, unlocking EV adoption for millions more drivers. Maintaining a sub-$16,000 price indefinitely may not be feasible. Market volatility, material shortages, and policy shifts could force adjustments, but Tesla's innovations, from efficient unboxed manufacturing to localized supply chains and software-driven revenue, give it tools to delay price hikes while scaling rapidly. In the near term, this means hundreds of thousands of drivers could access clean transportation at a price once thought impossible. More importantly, it redefines expectations. Innovation doesn't need to be expensive, only smart and scalable. Why should you buy Model 2 as soon as possible? The announcement that Tesla's next-generation $15,990 vehicle will debut next year is certainly exciting news for customers like us. At least it means we won't have to wait until 2026 or later. To clarify things further, let's analyze a few key factors related to the production process and leaked timeline of Tesla's Model 2 project, as they offer a broader view of Tesla's progress leading up to the official launch. In Tesla's second quarter earnings call, Elon Musk has confirmed Tesla is now at a very advanced stage with this next-generation affordable model. Advanced stage here likely means they are in the final steps of development, or perhaps even finished, simply waiting for the right moment to unveil the vehicle next year. The Model 2 became widely discussed when Tesla announced its unboxing process, the company's most efficient and advanced manufacturing method to date. If you're not familiar with it, this is a new production approach that Tesla originally planned to roll out exclusively at Giga Mexico for the next-generation vehicle. However, due to urgency and delays in the Mexico facility, it now appears that the process will be implemented at Giga Texas instead. Tesla Vice President Lars Moravy said in a previous investor call that, when you have a car that's about 5 meters long, you'll have people working around it, like we did with the Model 3, he explained. We're going to change this process by using different parts of the vehicle and enabling multiple tasks to happen simultaneously, similar to what we did with the Model Y's structural battery pack. This allows us to have more people, or robots, working on the vehicle at the same time. This new process is designed to simplify production, cut manufacturing costs by 50%, and reduce factory floor space by 40%. Under this approach, main components such as the outer panels, doors, and front end are painted separately and then assembled together in the final stage. Sub-assemblies are put together independently, while the structural battery pack, which also includes the seats, is lifted into place from below. The unboxing process is supported by large Giga castings and the structural battery pack. Recently, it was revealed that this process is being developed on an entirely new platform called NV9X. Though, it's still unclear what the abbreviation stands for beyond being referred to by Tesla as the next-generation vehicle. According to several reputable reports, Tesla's initial production target for the Model 2 at Giga Texas is around 10,000 vehicles per week, or roughly 500,000 units per year. While this figure is significantly lower than the company's broader goal of 4 million low-cost EVs annually, production could ramp up quickly, potentially reaching 2.5 million Model 2 units by 2026, distributed across Giga Texas and other factories. So in the end, can Tesla really deliver a $15,990 Model 2 without compromising quality or range? Please share your opinion in the comments section below this video.
It will be an age of abundance, the likes of which people have almost no one has envisioned. It'll be something special.
It took Tesla several years to perfect a new car, but once it enters production, the process only takes a few minutes and now, just 30 seconds. Yeah, 30 seconds or even less to build a brand new car, and that car is the CyberCab, Tesla's self-driving robo-taxi. Of course, producing a CyberCab in 30 seconds using a traditional assembly line would be impossible. Even this car is unlike any other Tesla vehicle. That's exactly why Elon Musk is using what he calls the Unboxed production line, a revolutionary EV manufacturing process, unlike anything the world has seen before. Elon Musk has talked about it for years, but only now are we finally seeing the real details. And this is how Tesla's Unboxed production line is set to transform the global auto industry. We believe Chinese competitors will soon try to copy this system. Discover it now. Okay, you might not know this, but for more than a century, the automotive industry has barely changed in how cars are made. We mean, real innovation in the production process has been minimal. Ever since Henry Ford introduced the Model T, the first Ford car to be mass-produced on a moving assembly line, the traditional assembly line model has remained the backbone of car manufacturing around the world. Of course, robots, AI, and automation have been added over time, but the core structure of the production line, where a car moves through hundreds of assembly stations until completion, has essentially stayed the same. However, Elon Musk recognized both the strengths and serious limitations of the traditional assembly line. It's slow, expensive, and filled with countless points of accumulated error, all of which make it impossible for Tesla to significantly reduce production costs and offer truly affordable cars. That's why Elon Musk and the Tesla engineering team have spent years developing a completely different kind of production system, and now they've finally succeeded in creating the Unboxed production line, a complete reinvention of how humans build cars. So, what makes Unboxed production line so special? Okay, if the traditional assembly line is like a continuous flow, where each component is added one by one until a finished car rolls out, then the Unboxed production line takes the exact opposite approach. It breaks that flow into multiple parallel branches. Tesla has essentially broken down the assembly line into independent modules, with each module responsible for building a specific section of the car, for example, the vehicle floor system, front frame, mid-body, or rear cabin. Each of these sections is produced separately on a dedicated, highly optimized line designed for that specific task. Once complete, all the sections are brought together simultaneously at a central junction point, where the entire vehicle is merged in an instant. This structure allows Tesla to cut assembly time from hours down to just a few dozen seconds. What makes the Unboxed process truly special isn't just its speed. It's how Tesla has completely reorganized its entire manufacturing value chain. Instead of painting the entire car body after assembly, Tesla paints each body panel individually before they're joined together. What makes the Unboxed process truly special isn't just its speed, it's how Tesla has completely reorganized its entire manufacturing value chain. Instead of painting the entire car body after assembly, Tesla paints each body panel individually before they're joined together. Every component is finished independently, fully ready to be attached to the frame without needing to go through a full body paint or treatment process afterward. This approach requires extreme precision, because even a tiny scratch during assembly would mean that panel has to be discarded. Tesla solved this challenge with a brilliantly simple innovation: robots equipped with vacuum suction cups. These robotic arms use negative pressure to securely hold and move the painted panels without ever touching their surface, preventing any damage to the exterior finish. After the robots precisely position each component, Tesla doesn't use rivets, bolts, or welding like traditional automakers do. Instead, they rely on a high-strength industrial adhesive, a bonding material with incredible grip and flexibility, strong enough to hold metal panels together even more securely than spot welding. Okay, that might sound risky at first, but technically, it makes perfect sense. You know, when a car is in motion, its body structure constantly experiences heat changes and vibrations, which can cause welded joints or bolts to expand, contract, or loosen over time. Industrial adhesive, on the other hand, can absorb vibrations, reduce noise, and self-compensate for expansion and contraction, resulting in a smoother, quieter, and more durable ride. Yeah, Tesla calls this layer the engineered adhesive gap, essentially a precisely calculated adhesive layer designed to compensate for even the tiniest tolerances and misalignments in the vehicle's frame. In the current production line, workers have to manually align each metal panel, which can easily lead to misalignments in different areas. However, Tesla's robots use a global datum, a system of global reference points on the vehicle frame. Each robot arm is programmed to place body panels with millimeter precision, ensuring the entire car is aligned according to a single coordinate system, rather than just individual sections. As a result, the panel gaps, once a weakness for Tesla in the past, are now perfectly managed. Of course, using adhesive also comes with a challenge. The glue needs time to dry. But Elon Musk doesn't accept waiting for the glue to dry. Tesla's new patent offers two unique solutions: temporary locator pins and hot melt adhesive. The locator pins help secure the body panels immediately after bonding, while the hot melt adhesive acts as a temporary glue to hold the parts firmly enough for the main adhesive to fully cure. This allows the production line to operate continuously, with no downtime. The effectiveness of this method is nothing short of astonishing. According to Tesla's calculations, the company has reduced the number of mechanical fasteners by 65%, while spending only about $25 worth of adhesive per vehicle, a figure almost unbelievable compared to the hundreds of dollars typically spent on traditional welding and bolting systems. Every aspect of the Unboxed process is built around the three core principles Elon Musk always emphasizes: faster, better, cheaper. This parallel production architecture also allows each module to operate independently and with greater flexibility. If an issue arises in one section, Tesla can simply pause that specific module for maintenance while the others continue running normally. This creates a level of scalability that no other automaker has achieved. When production needs to ramp up, Tesla doesn't have to build an entirely new assembly line. It simply adds more parallel modules. That's the fundamental difference between Tesla's Unboxed production line and traditional manufacturing systems. One is a linear process, while the other is a modular network that can be infinitely replicated. But that's not even the most surprising part. You know, beyond improving speed and cost, the Unboxed system also delivers consistent quality by eliminating human error. In traditional assembly lines, each worker or robot is responsible for a specific section, meaning small misalignments can accumulate as the vehicle moves down the line. With Tesla's central coordination system and global reference network, however, every component sees the car as a whole, allowing for perfectly precise alignment across the entire structure. This is why Elon Musk believes that Unboxed isn't just a technical upgrade, it's a manufacturing revolution, on the same scale as Henry Ford's invention of the moving assembly line more than a century ago. It's not in Asia or Europe. The first Unboxed production line is being installed at Tesla's Gigafactory, Texas, where the company will build the CyberCab, Tesla's first fully autonomous taxi. According to experts monitoring the factory via drone footage, robotic equipment, vacuum arm systems, adhesive reservoirs, and separate paint modules have already been delivered and assembled on site, all set for the next phase of operation.
The design of the CyberCab line it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. It's, in fact, the line will move so fast that, that actually people can't even get close to it.
Elon Musk once remarked that the speed of this production line is so fast, it would be dangerous for humans to get too close, similar to the robots used in Amazon's fulfillment centers. Tesla's goal is to reach a pace of one fully assembled vehicle every 5 seconds, roughly 4 to 5 times faster than the current average production rate of the Model 3 and Model Y.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
Of course, that level of speed won't happen right away. When the new line first goes into operation, production might start at 25 to 30 seconds per vehicle, and then be optimized over time. If this vision becomes reality, its impact on the global automotive industry will be enormous. Manufacturing has always been the bottleneck that determines how scalable a car company can be. Once Tesla can produce 2 or 3 times as many vehicles with the same resources, the cost per unit will drop dramatically, paving the way for much more affordable electric cars. This wouldn't just solidify Tesla's leadership position, it would also force competitors, especially Chinese automakers, to race toward copying or improving upon a similar model. Manufacturers like BYD, XPeng, and Xiaomi, known for their speed in learning and optimizing production, will likely develop their own variations of the Unboxed concept soon. However, the true value of the Unboxed production line isn't merely in building cars faster. It lies in the philosophy of reimagining the entire manufacturing system from the ground up. Tesla isn't trying to make the old assembly line better. They're erasing it and rebuilding from scratch, just as they did with batteries, autonomous driving software, and the direct-to-consumer sales model. If this new line runs smoothly, 2026 could mark the dawn of a new era in electric vehicle manufacturing. One where a car is built in just a few seconds with no smoke, no welding sparks, and no rows of human workers. This may also be the closest step yet toward a fully AI and robot-driven automotive industry. Elon Musk isn't just building electric cars, he's redefining what a factory means in the 21st century. A place where speed, precision, and efficiency reach levels that humans can only stand back and watch in awe. Most importantly, thanks to this production system, the CyberCab is expected to cost around $30,000 per vehicle. And it's believed that Tesla's upcoming Model 2, part of the NV91 and NV93 projects, will also be produced using the same revolutionary Unboxed production line. Alongside the E41 and D50 versions, as standard versions of the Model Y and Model 3, Tesla is also reviving the NV91 and NV93 projects, according to internal sources. These are variants of Tesla's most affordable $25,000 vehicle, tentatively referred to as the Model 2, which is being developed in the United States under the codename Project Redwood. Specifically, NV91, short for New Vehicle, is currently in an advanced stage of development as an affordable crossover-style car inspired by the Model Y, but with a smaller battery pack and a more compact design. This elusive $25,000 vehicle was the one Tesla initially put on hold in order to focus on bringing the CyberCab and Robotaxi platform to life, while also simplifying and streamlining features in the existing Model Y and Model 3. However, at the time, Tesla's chief designer Franz von Holzhausen stated that rumors about Tesla abandoning the $25,000 Model 2 were greatly exaggerated, urging everyone to stay tuned. According to Elon Musk, the upcoming Tesla Model 2, the company's most affordable car, will be smaller and more streamlined, equipped with a 54 kilowatt-hours battery pack capable of delivering around 250 miles of range, and featuring next-generation AI-5 full self-driving hardware. This suggests that the Model 2 could debut as early as the fourth quarter of 2026, which aligns with Tesla's expected timeline for installing the HW5 computer and new camera system in its vehicles. That timing also matches earlier reports claiming Tesla would only unveil the $25,000 Model 2 in 2026, after rolling out upgrades for all existing models in 2025 and introducing base standard variants to maintain profit margins, before taking on the company's most ambitious challenge yet, producing its first true mass-market EV with a planned volume of 4 million units. Tesla is currently selling the Model Y standard in Europe, just 3 days after its debut in the United States. However, while the US launch, now more than a week old, has faced widespread criticism for the large number of missing features compared to the relatively small price reduction, the European version tells a different story. The model released in Europe comes with fewer feature cuts and a larger price gap, making it a much more compelling proposition in a region where Tesla's sales have been declining rapidly. Although many customers initially dismissed the car, we believe this is not merely a stripped-down Model Y, but a distinct variant in its own right. It features a redesigned front bumper, no light bar, and simplified taillights, all part of Tesla's effort to reduce production costs while maintaining a fresh design identity. With a 5-seat configuration for adult passengers, the Tesla Model Y Standard still offers an impressive maximum cargo capacity of 2,096 liters, along with Tesla's signature 8-camera safety system. Inside, you'll notice fabric seats, a first for any Tesla model, paired with a simplified center console featuring a spacious storage area and a floating armrest reminiscent of the Cybertruck's interior design. The Model Y Standard doesn't include a glass roof, and it rides on 18-inch wheels uniquely designed for maximum aerodynamic efficiency. Despite the cost-cutting measures, the Model Y Standard retains all the core features you'd expect from a Tesla. It still uses the 15.4-inch central touchscreen, though the 8-inch rear display has been removed. The car comes equipped with adaptive cruise control compatible with Tesla's full self-driving features, as well as smartphone key functionality, allowing your phone to act as your car key. The Tesla Model Y Standard is powered by a single electric motor driving the rear wheels. Equipped with a 69 kilowatt-hour standard battery pack, this crossover can accelerate from 0 to 60 miles per hour in 6.8 seconds. In terms of range, Tesla claims the Model Y Standard can travel up to 321 miles on a single charge, 10 miles more than the regular rear-wheel drive Model Y. It also supports 225 kilowatts supercharging, allowing the vehicle to gain about 160 miles of range in just 15 minutes of charging. The Model Y Standard is currently being built at Tesla's Gigafactory Texas in Austin, and drone footage shows a large number of these vehicles already rolling off the production line, indicating that Tesla may be ramping up production of this new Model Y variant at the facility. Priced at $39,990, however, the Model Y Standard is still seen by many as not quite affordable enough to meet customer expectations, especially among those who have long been waiting for a truly mass-market Tesla EV. The challenge is that in today's increasingly competitive EV market, $40,000 remains a steep price for the average consumer, both in the US and globally. Many had hoped that the standard version would bring the Model Y closer to the symbolic $35,000 mark, the price point Elon Musk once promised when he spoke of building a Tesla for everyone. At its current price point, the Model Y Standard may be cheaper than the long-range or performance versions, but it still remains out of reach for many middle-class families. With auto loan interest rates still high and insurance costs rising sharply, even a few $1,000s in price difference can significantly impact a buyer's decision. Tesla now faces the reality that, in order to expand its market share and sustain growth, it needs not just premium models, but also truly accessible vehicles, priced under $35,000, or ideally in the $25,000, $30,000 range. Another factor making the Model Y Standard less appealing is growing competition from emerging rivals, particularly Chinese automakers like BYD, NIO, and XPeng. These companies have already launched electric SUVs priced between $25,000 and $30,000, offering comparable range and technology. In Europe and Asia, affordable EVs are quickly gaining market share thanks to lower production costs and more efficient battery supply chains. If Tesla fails to respond swiftly, it risks losing the leadership position it has spent the past decade working so hard to build. Moreover, consumer attitudes are shifting. Increasingly, people no longer view electric cars as luxury items or tech status symbols, but simply as everyday transportation tools. What they want is an EV that's simple, safe, efficient, and equipped with just the essentials. Meanwhile, Tesla continues to position and price its vehicles as premium products, a strategy that's now driving many potential buyers toward more affordable alternatives. For this reason, analysts believe Tesla's next strategic move must be to launch a sub-$35,000 vehicle, possibly the long-rumored Model 2 or an entirely new variant, built on Tesla's next-generation gigacasting platform. If Tesla succeeds, it could dramatically expand its global customer base and strengthen its foothold in the mass-market EV race. At that point, Tesla would truly be fulfilling Elon Musk's original vision, to make electric vehicles something anyone can own. Okay, above all, what do you think about Tesla's new Unboxed production line? Do you believe this could really cut car production time to just 30 seconds? Thanks for watching, everyone. If you enjoyed this deep dive into Tesla's Unboxed production line, make sure to hit that like button. Subscribe for more tech breakdowns and turn on notifications so you don't miss our next video. Goodbye.